My name is Klaus Abelgren. I'm head of business development for Bigfinite. Bigfinite is a cloud data analytics platform to help drug makers or manufacturers improve their operations and take drug products more effectively to market. If you are in the business of making drugs or a drug manufacturer, every single company is faced with increasing pressure, so kind of the pressure is on to perform. Whether it's from the fact that almost half of new drugs approved last year were personalized medicines with a batch of one, or it's the fact that your average tenure for your market-leading drugs is half of what it used to be, or the fact that new biotech processes, the facility footprint and then intensification of those processes, it just drives dramatic changes in the manufacturing capacity needed. Essentially, the days of building a manufacturing site for a single product for the next 20 years, those days are over. It is further kind of added to the fact of the pressure that everybody's experiencing that according to McKinsey, only the public sector is less advanced in adopting technology to drive forward your business. Other data points from Gartner point to $50 billion being wasted because of the high levels of regulations, but in the US manufacturing alone, or the fact that 70% of all available data, either in paper batch records or otherwise, not being effectively utilized to drive a better understanding of your operational realities. So that lens, or kind of the net effect of this, is a situation for the people that we speak to at the large global pharma manufacturers, is this dramatic contrast between where you know you want to go to or where you want to be and the day-to-day experiences of what is your daily operation, your daily life. So you know you need to improve or how to meet your manufacturing goals. You know you need to get safe and high quality drug products to the deserving patients. You know you need to always ensure data integrity and avoid, I'll call it, the warning letters from the FDA. But it's greatly inefficient the way that most manufacturers try to do that today. So you have to employ a lot of teams and people and time spent in chasing down the information to understand root causes of waste or scrap that has occurred. So even in a highly regulated and traditionally conservative industry, there's a tremendous push to a kind of a transformation or digitalization of operations and how we make better use of technology and available data from your manufacturing operations. A lot of it is kind of put under the label of Pharma 4.0, but independently of what label we put to it, at Bigfinite, we believe one of the kind of the true root causes of why it remains a challenge after decades of effort, of automation systems, of reporting systems, etc., is the fact that we suffer an incomplete understanding of what drives variation in your manufacturing processes. There's a lot of factors that contribute to that, both kind of process specifics in your fermentation units, in your operations, in the clean rooms, as we talked about earlier, the human factor, the environment, the raw material variation. There's a lot of things that contribute to a less than optimal outcome of manufacturing operations. We believe that there's an opportunity to do something about that. So whether it's McKinsey stating that advanced analytics and AI learning can drive a measurable impact on the bottom line, the EBITDA, or the bottom line, we believe that with using currently available technologies for big data, machine learning, and pattern recognition, that we can help manufacturers gain a better understanding of the complete picture of what drives operational performance, what impacts variance in my physical processes and the human processes that are being used to make drug products today. So the question, the simple question we often ask is, if you had all the available information readily available at your fingertips, what type of problems would you address? What type of bottlenecks would you try to remove? What type of processes would you look to speed up in your operations today? So we picked a couple of quick examples, and then we're going to show a quick little demo to give you a sense of what is practically possible, the type of projects we work with clients on today, of making machine learning, AI more approachable and being practical in how it's being deployed today and not tomorrow. So this is an example of work we're doing with Novo Nordisk, the largest insulin maker in the world. They've been using OEE, overall equipment effectiveness, for decades, but felt they were kind of flatlining on performance. They had too many days where the desired OEE, kind of the line performance indicator, wasn't up to where they was expecting it to be, even with continuous improvement effort and constant monitoring of that. We helped them gain a better understanding of what were contributing factors to stops, whether it's stops that kind of halt the line entirely or these micro stops that detract from getting product off that fill or the assembly lines where they make the insulin pens. And specifically, so one, it includes breaking down data silos, so real-time visibility in a web browser of my current performance. Let me see if I have a pointer on this guy. Oh, anyways, I'll do this. I have a pointer. It starts with the visibility of my predicted performance of my current run. So instead of just have a lofty goal that was set when the line was commissioned, but you know you're never gonna attain, we can now help them understand with the current operating conditions, the line speed and the state of the equipment, what are you likely to be your end of run number of units that you have produced. So that helps them, that motivational factor, say, hey, am I within reach of my goal in my current run for my current day? But what has turned out to be a true game changer has been, we can also, based on, I think it's a random forest regressor, but an AI model, a predictive model on the combined set of data, not just kind of the line data and the stops, but the type of carton they're making, the day of the year, and the environmental factors. All of those factors put into a predictive model to say, hey, based on the combined set of operating conditions, the most likely next stop you're going to experience is in this substation, the label supply or the whatever kind of, there's 100 substations in that automated line. So the personnel on the line, the maintenance technicians, they can, in a tablet on the web browser, be guided in advance of experiencing stops, what should I pay attention to? And specifically, if they can see, hey, I'm 15 minutes ahead of my plan. So if I go and I see it's likely that I'm going to have a stop on the carton or whatever else supply, let's tweak it, let's test it, let's stop it for a moment before it stops the entire line. So it's making a dramatic impact on the number of stops and scrap that I had to throw off the line. And again, it's really just a starting point for understanding, okay, what else can the data tell us when I'm operating at maximum capacity? So they label it real-time failure diagnostics. It includes the OEE, but it's really that proactive guidance to the line, the people closest to the process, that makes a real difference. The second quick example we picked was work with Shire, now Takeda. They have a continuous fermentation upstream process, and then in single-use bags in the deep freezer. When they have to prepare the downstream purification run, they have to be conscious about which bags to pick out to kind of plan for that entire campaign. A campaign is typically 6 runs in the downstream process. But if I have a set of kind of CQAs or CPPs, I have to, requirements in my control strategy that I have to fulfill. But even if I meet those, am I optimizing for the output, the yield, the total protein concentration at the end of the downstream process? What if I use all the good bags or the best bags in the first run and then suffer 3 poor runs afterwards? That would decrease my yield of that downstream process. So what we helped them do was a tool to say, hey, we can help you predict the total protein concentration after downstream based on all the data we have available from the upstream process. How was each bag made, what was the CQAs, what was the raw material, everything combined, the batch records, the LIMS data, everything taken into one. A predictive model say, hey, I'm first suggesting bags to pick for all the 6 runs. Every single run is meeting the hard requirements or criteria. But then I can start optimizing. But if I move this bag, or there's a hold on this bag, so I save it for later, or I'm also anticipating other bags, I can optimize for the total output and help them ultimately increase the yield of the process, but more practically save a lot of time and effort they would normally spend manually collecting that data and generating these run sheets or these what do you call the strategy documents, pooling strategy documents. It's part of the batch record. But also, I think the biggest impact has been avoid the risk of, again, using all the good bags first and sacrificing later runs. So it's another practical example of where a broader set of raw data sources, a predictive model, helps operationally kind of add value in the process today. So 2 quick examples to say it's being deployed in production and in kind of regulated environments today. Bigfinite as a technology provider, we offer the ability to connect to these siloed data sources and activate kind of the GXP data that's out there. We offer what we call a regulated, sorry, I'm in the way. We offer what we label a regulated data lake, which means on Amazon Web Services, a data lake that you ingest data from multiple data sources. Every single data item is wrapped in what we call a GMP envelope to ensure data integrity and Alcoa Plus principles. And then on top of that platform, we offer our customers the ability to offer very tailored, specific or purpose-built solutions that address specific use cases or problem statements. So the 2 examples I saw before was just 2 of any number of solutions that you can build on top of the analytics platform. Quick demo. It's run automatically, so it should go well. You log into a website, everything is in the cloud. The only component you install within your own domain is what we label a data feeder. A data feeder is a very simple software agent, a piece of Java code that it becomes kind of your digital twin. It installs as an executable, maybe 5 megabytes, automatically connects to the cloud, finds its twin, understands what data to query and what data to ingest to the cloud using IoT. In that process, we put that GMP envelope around the data that ensures the full life cycle of every single data point, original value, geolocation, hash key, everything that is being maintained for the life cycle of that data item being used. Once we have the data in the data lake, what excites me the most as an 20-year automation engineer is you're not dependent on a single, what we call a semantic model of how data should be used. It doesn't have to be an S95 standard or S88 or allotrope. You can have multiple ways to activate and make use of that data in your analytical models. So this is a simple example of a solution, a dashboard you built to allow upstream operators in the fermentation process trying to understand how do I predict a titer in my fermentation 30 minutes in advance or 2 hours in advance. So trying to understand what has been the root cause of excursions I've seen in the past. I might have had, how we call it, foam out, I might have had fungi, I might have had different things occur that is non-desirable. How do I develop a more complete understanding of the patterns of data that led up to those, both to either record out a kappa or better understand what are the things that impact operation. We had an example where they detected a kind of a scientific relationship or correlation between peak humidity in media prep room 2 weeks in advance of the fermentation run. That's not something you would normally kind of find in classical statistical analysis. It's looking across that patterns from a much broader perspective and multiple data sources. And again, each of these screens are based on what we call widgets in the software. So they're designed say, according to your needs. You can drag them around, configure them according to which user you're trying to help. And based on kind of the starting point being what we call root cause analysis, how to get to a better understanding of kind of how those bad events occurred. The next logical step is to say, how do we avoid that event or those conditions from occurring again? We don't want repeat incidents of any kind. So the next step is using the same principles. I guide maybe a different screen to say, hey, how can I predict the risk of abnormal events or conditions to occur? So in this case, this is a supervised AI algorithm where I've selected any number of data sources to predict my titer as the output variable. In real time, it monitors all the conditions from limbs, from the process control systems, alarm data, whatever is relevant of those parameters, and gives me that view of, hey, you are at risk within the next 2 hours to suffer kind of conditions that we know to be bad from the historical patterns that we have observed. So we trained the model on a couple of years of history, for example, and that helps us in real time constantly monitor those conditions and take action, take proactive action before I suffer a loss or an abnormal event again. I think this is a simple simulation. Again, it's a simple demo, but the ability to be alerted proactively and not kind of just do a quicker root cause analysis, but to prevent it to begin with. I think this is where the big data approach gives us new capabilities that's been difficult historically with traditional analytical approaches. So I think just to round it up with a call to action to come and see us at booth 241, almost at the far side here. Bigfinite is still a software startup. We are working with a lot of exciting companies. It's still early days, I think, as an industry. Gartner recognized us as the first vendor to provide a cloud platform for fully validatable solutions. That has a lot of implications with AI, machine learning algorithms, and how those are qualified. And we've also been formally invited or accepted into the FDA's Emerging Technology Team program. So we have a kind of a recurring, frequent dialogue with the FDA. How do we as an industry interpret the output of a black box AI predictive model? How can I trust that I should increase the temperature in my fermentation because the model told me to? So we're very excited to contribute to the broader industry of advancing, hey, how can we take advantage of technology that's much more approachable today and operate more effectively at the end of the day? So I think that was the call to action. Come see us at the booth. We have water bottles, we have candy. We love to talk to you. Thanks, everyone.